So guys, welcome to the second part of this tutorial on segment tree where I am updating an element in the input array and seeing that some elements get affected in my segment tree. Okay, so first of all, before moving on to code, let's see how this segment array is represented in form of array. So it's just similar to the binary tree. If you the binary heap, if you look towards it, this is 15 the first element, then 4, then 11, then 1 3 9 2. This is the way we represent it in an array. This is the way the segment array is represented. Okay, so guys, if you see, this property will also follow that if I take a node at index I in the segment tree, its left child would be 2i plus 1 and right child will be 2i plus 2. Okay, so this is the property which we are going to use, okay, within our code, because we just need these indexes where we are updating the nodes in the segment tree. Okay, so in this case the index is 0. This is 0th index of the segment tree and we are updating the value on the 2i plus 1, 2 into 0 plus 1 and 2 into 0 plus 2. Okay, this is not getting updated because this condition fails, so we will be checking that condition first and then updating. Okay, so as I see, I need to pass the first starting index, ending index, the index which I need to update in the array, and of course the segment tree, because I need to update that in which location my segment, the element in the segment tree will change. So I need the segment array too. Okay, so and will I need anything more? Yes, I will need the difference which I need to update over here, like difference is 1, so I will also pass a difference of 1 over here. It means that updated value minus the old value, 4 minus 3. Okay, so let's look at the code, guys. Okay, if you see, I am making a function called update element. I am passing the segment array. Okay, I am passing the first 0 to n minus 1. That would be my starting and ending index of the array, of the input array. Remember that 0 and n minus 1 are the index of the input array, because that's how it was here. 1 4. Okay, 1 was the starting index, 4 was the ending index, and over that range only we are checking. So that's what we need. So this is it, and of course we need to pass the index I where I need to update in the input array. So in this case it's 2. Okay, so next thing is of course the difference which I need to update. So in this case it was 1, 4 minus 3. So that's the amount by which we will update or increment my value in the segment tree. Okay, and of course initially I am calling this function on the root of the segment tree, and we know that the root of the segment tree will always be the index number 0 of this segment array. Okay, so I call this function, okay, once. Okay, and I know that my this function is such that it will recurse and find everything for me. Okay, so if you see, this would be my declaration. Of course I have called this function on the root of segment tree. Okay, only once or only start. Okay, so this is how it goes, and of course I will need to pass the start and the end index, okay, of the array. So this is the end, and of course I need to pass the index where I need to update the element, and I need to pass the difference. Okay, and I need to pass the index where my update will be taking on the segment tree. So as you see, I passed 0 over here. So but every time when we'll recurse, this will be, I am naming this as seg I. Okay, this would be the index where my update will take place in the segment array. Okay, so now we are gonna recurse. Okay, so first of all, as you saw that we were checking that whether this index 2 lies in this range or not. So let's write that out. Okay, if I is less than start, okay, it means that my I falls, my this index which I will be checking will fall out of in the left side of this array. Okay, if this is true, or if I is greater than the end. Okay, so of course this means that my index which I am looking for is outside the range. Okay, so I will simply return. Okay, if this is the case, as we did over here, 2 completely was not lying over this range, so we returned. So what would be our next step? As you know that the next step is that we are updating this value and recursing onto the left and right childs. So how we are going to update? We are going to update the segment array on the index, of course, which I am taking over here. So seg array segi is equal to, so I have to just update this element by the difference. Okay, I am going to update this by the difference. So what would be my next step? As you saw that we were recursing onto the left and right subtrees. So guys, this, what do I mean by left and right subtrees? Actually, when I'm writing the code over here, I don't have any reference of the tree. I just have this start, end, and all these parameters. So just when I will recurse, I just need to change the values of this start and end. Okay, and nothing else. Okay, and I just need to tell that, okay, this time this 2i plus 2 node will be my target, and here 2i plus 1 will be the target, and here 2i plus 2 will be the target. So this time I call the same function. Okay, update element, but this time with, of course, segment array will go always. And next thing is start index will also go. As you see, this one is completely same, but this 4, as you see, is half now. So we have half the range of this particular thing. So my this will be, of course, mid. Okay, and what is this mid? My mid element is the start plus end by 2. Okay, so this is my mid, and another element is, of course, this index will remain always same because this is the element which I am always passing. This is the index which I am always passing on all the recursive calls. Okay, so this will be my index, and of course the difference is always same, but this time, as you see, the target element is target index of is 2i plus 1. So this time it would be 2 into seg I plus 1. Okay, this is fine. And again, as you see, I am copying and pasting it for the second half. Okay, as you see, this would be my mid plus 1 to end. Okay, so this time I would be just calling it with mid plus 1 and end. Okay, and this would be, of course, the target element now is 2i plus 2. Okay, so guys, I think this is okay, but one thing more is that we need to keep checking that this start index and end index does not cross their limits. Okay, so this start, whenever is not equal to the end, then only I am doing these particular things. Okay, so this is the final code, I think. Okay, so this is how we, so guys, this is the first call. Okay, So this is the first call, okay, and from here the function declaration. So this is the thing. And why did I apply this condition over here? Because I just want to do when my array size is not 1, okay. As soon as my array size will be 1, I will just not, I know that I have reached the leaf and I will not go further, okay. So this is the thing, guys. This is how segment tree update occurs. And if you see, it's hard to find, but this is a log n operation. It means that it would be happening over the in the complexity of the height of this tree. But how is it happening? Because every time we are not we are not just blindly recursing on all the nodes, okay. It's not like a normal DFS which we are doing. What we are doing, we are applying a very helpful condition that this index should lie over this range. That's why many of the elements will get discarded, many of the recursive calls will get discarded. So it will turn out to be a log n operation. So this update element in the input array takes my log n complexity, okay, where n is the elements in my input array. So bye guys, thank you for watching. Good night.